Tonight's video is the second video in the Castaway unit, and we're going to discuss physical properties, density, and state of matter. We have two objectives for tonight's lesson. The first is to be able to explain the relationship between volume and mass for density. The second one is to be able to construct a response explaining the difference in the state of matter. All 118 elements are able to exist in all three states of matter, and those include solid, liquids, and gases. When we talk about moving between a solid and a liquid phase, we're talking about freezing and melting. If we're talking about going between a liquid and a gas phase, we're talking about vaporization and condensation. The last type of phase change that you'll see for state of matter between solids and gas would be sublimation or deposition. The picture on the slide here shows what a solid looks like at the atomic level. And if you look at it, all the molecules in it are tightly packed together, so there isn't any movement to them. The only movement that occurs is slight vibration of each of the molecules in that solid. And it's this packed organization that allows a solid to have a definite shape and a definite volume. And what I mean by this is the shape of a solid does not change to fit its container, or the size to fit its container either. So with it being as packed as it is, this also means that solids are not easily compressed. Liquids are the second state of matter. And if you look at the picture on the slide here, you'll notice that the molecules are not as packed together as they are with solids. And because they have a little bit more space, the molecules in a liquid can move slowly and rearrange themselves. And so what this means here is that if I have a glass of water like this, and you'll notice how it takes the shape of the container here, and I were to pour it into this Tupperware container, the water molecules are going to rearrange themselves to take the shape of the container. Now, because they are still closely packed together, what this means is that the volume is not going to change. Okay, the volume of this cup and the volume of the water here are still exactly the same. It may look different, but they're the same. And so it takes the shape of the container, and you can compress liquids, but not very easily, and this is often referred to as hydraulics. Gases are the last state of matter that we need to talk about. And if you look at the picture here, the gas molecules are much more spread out than they are for solids or liquids. And as a result, the only time that a gas molecule comes in contact with another molecule is when it collides with another gas molecule or the surface of a container. Because of this, gas molecules have an indefinite shape. They take the shape of whatever they're in. And they also have an indefinite volume. Because of their movement, they again spread out to fill the entire area. And so gas molecules are easy to compress, and we use this property for things such as tires. When we talk about state of matter, it's also important to discuss melting and boiling points. These are also physical properties for any element or any compound. And so pictured on here, I have a glass of ice that has liquid water in it and also has steam above it. So water freezes at 0 degrees Celsius and becomes a solid block of ice. And water also then boils at 100 degrees Celsius and turns into a gas when it turns into steam. Iron, which you see every day as a solid, can also be a liquid or a gas if you heat it up to a high enough temperature. So in the picture above, I have molten iron that's being formed into steel. I have a video of solid tin that I heated up over a Bunsen burner in the lab that gets up to about 350 degrees. And as the heat approaches the melting point of tin at 315 degrees, we can turn tin from a solid into a liquid. And that's what I'm going to dump out on the paper at the end there, where it will quickly cool and freeze back into a solid at about room temperature. The next physical property that we're going to discuss tonight is that of density. And what this is the relationship between the mass and volume for an object. So density is equal to the mass for a given object divided by its volume. And water's density, which is extremely important for life, is 1 gram per milliliter. So I have pictured on here an iceberg, which, if you know, ice is less dense than water, and so it floats. The physical property of density is extremely important to real-world applications. If ice was denser than water, what would happen during the winter is that as the water freezes, it would sink to the bottom. And if you were a fish inside of a lake, this would probably be detrimental to your health, as the entire lake would freeze and you would most likely perish. Density is also extremely important for why boats float. Boats make use of steel, which is denser than water, and theoretically should not float. But what happens is, inside the boat there are pockets of air in all the rooms or storage areas within the boat, and it's this air that's less dense than water that allows a boat to be buoyant. Lastly, if you were to look at like a hot air balloon or even a helium balloon, density of the air inside that balloon is less dense than the surrounding air, and that's why those balloons are able to rise into the air. Tonight is, if I were to make soap bubbles that had methane inside of them instead of air, would the methane bubbles rise into the air or would they sink? The question is methane denser or less dense than air?